Welcome back to lesson 34, where we analyze vector velocity and vector acceleration. So we are going to do this temporarily to practice the definition of the vector velocity. The vector velocity is the change in the vector position per unit of time. So the vector velocity is just v is just the change in the vector position per unit of time, while the vector acceleration is the change in the vector velocity per unit of time. We make the derivative of a vector value function like the position or like the velocity. So let's go to do these problems. The first problem says find the velocity and acceleration for the vector value function r of t that is e to the minus t I plus e to the t j. So this vector position is a function whose x of t is changing in a way like the equation say that x of t is e minus t. So at t equals 0, x of t is 1. At t equals very big, t equals infinity, x of t is 0. And while y of t is e to the t. So as t grows up, y of t grow up very, very much. So it say find the vector velocity, find the vector, and we can find also the speed if you want. The vector velocity, the speed is just the magnitude of the vector velocity. The vector velocity is the derivative of the vector position respect to the t, or the derivative respect to the t of the vector position. The vector position is e minus t I plus e raised to the power t j. So this is a function that depends on t, and we need to make the derivative. The derivative of e minus t is minus 1 e minus t. The derivative of e to the t is easy, is e to the t. So the vector velocity is a new vector whose function is a vector value function, and the vector value function is e minus ti plus e to the tj. You can picture with the position and the vector velocity for the position and the vector velocity for different times and see how they look. For example, for t equals 0, as I said, from t equals 0, the position is e to the 0 is 1. So this is the x, this is the y, and e to the 1 is e. T equals 0, e to the 0 is 1. So the vector position at t equals 0 is here. Well, the vector position at t equal infinity is e to the 0 is 1, e to the infinity is very big, so the vector position is 0 in the x, and very, very big, very, very big in very, very big at t equal infinity. While the vector velocity at t equals 0, the vector velocity is e to the 0 is 1 minus 1i plus 1j. Minus 1i plus 1j is this vector. Minus 1i plus 1j is this vector. So at the time t equals 0, the object has this vector position and have this vector velocity. At time t equal infinity, the vector position is very big, and what will be the vector velocity at time t equal infinity? Oh, also in the component x will be 0, and the component y will be infinity. So it would be very big, the position at t equal infinity, and the velocity will be like this at t equal infinity. So the problem says find the vector velocity already found. Is the derivative of r respect to the t. The problem says find the acceleration. The acceleration is the change in the vector velocity per unit of time of or the change per unit of time, or the derivative respect to the time of the derivative of r respect to the t. We have the derivative of r respect to the t, which is the velocity, this one. So the derivative respect to the t of the velocity is the acceleration. If you make the derivative of e minus t is minus 1 e minus t. With this minus, it is a positive sign here. So it will be e minus ti. The derivative of e to the t is easy, is e to the t j. So this is the vector acceleration, and this is the vector velocity. You can think about how is the acceleration at t equals 0. At t equals 0, the object have e to the 0 is 1, 1i, 1j. So the acceleration at t equals 0 is parallel to the vector velocity at t equals 0. Oh, no, it's not parallel. It's 1i plus 1j is perpendicular to the vector velocity. Is this vector. This vector is 1i plus 1j. So at the initial time t equals 0, this is the acceleration. This is the position, this one, and this one is the vector velocity. It's three vectors that pointing in different directions. As time goes and pass, the three vectors are changing, and at the end, the velocity at t very big, the velocity is pointing going up, the position is pointing going in this direction, and the acceleration when t is very big, the acceleration is also very big and pointing in the j direction. So at t very big, the three vectors are pointing in the same direction, in the j direction, but at the initial time, t equals 0, the three vectors are pointing in different directions. Let's go to do the next problem. Next problem is quite similar to the previous problem. Is find the velocity and acceleration when now the law, the position of the object is done by this law. Is natural log of ti plus t to the 4j. What is the velocity? The velocity is the derivative of the vector position respect to the time. What is the derivative of natural log of t? Is 1 divided by t. What is the derivative of t to the 4 is 4t cubed. So the vector velocity is this one. And the acceleration is the derivative respect to the t of the vector velocity. What is the derivative of 1 divided by t, or t minus 1? The derivative respect to the t of t minus 1 is minus 1 divided by t squared I. What is the derivative of 4t cubed? Is 3 multiplied by 4 is 12, 12t squared j. So this is the vector velocity, and this is the vector acceleration. You can plug in for different times t what will be. Don't use t equals 0, of course, because it will not be defined the velocity, and it will not be defined the position, because the natural log of t when t goes to infinity is when t goes to 0 is not defined at t equals 0. So you can place the three vectors, the position vector, the velocity vector, and the acceleration vector at t equals 0, and you can draw the three vector intermediate positions. At t equals 0, you cannot plug in, sorry, but you can plug it at t very, very, very small, you can plug it. T very small, you can plug it, but not at t equals 0. Okay, let's go to the next problem. The next problem is, again, the same thing. The only variant is that they say to find the velocity and the acceleration given r of t, but they say to find the velocity and the acceleration at the point x comma y, when x is t and y is 0. And the law of motion of this object is that r of t is 3ti plus t minus 1j. So what we will do to find the vector velocity, just find the derivative of r respect to the t. If you find the derivative of r respect to the t, you will find 3i plus 1j. So the velocity is a vector that now is constant. It doesn't depend of t. So in this problem, the vector velocity is a vector velocity that the object is moving in a straight line, because if the vector velocity is constant, doesn't depend on t, I and j will not change, so this will be the direction where the object is moving. So this is the vector velocity, and the acceleration, which is the change of the vector velocity with respect to the time. Because the vector velocity is constant, the acceleration, the change in the velocity respect to the time, if the velocity is constant, the vector velocity is constant, there is no change in the vector velocity, so the acceleration must be 0, as we have calculated here. So the only variant of this problem that it says that if it say find the velocity and acceleration not at certain time, find the velocity and acceleration when the object is passing through the position 3, 0. So x is 3, y is 0. So if x is 3, it means because x of t is 3t, if x of is 3, is because t is 1. So 3t is 3, so means that t is 1. Also, t minus 1 have to be 0. T minus 1 have to be 0, so t should be 1. So have to be the same time t when the object have the position x equals 3, y equals 0. So this time t equal 1 allow us to plug in into the vector velocity, but the vector velocity doesn't change. So the vector velocity v at the time 1 will be 3i plus 1j. And the acceleration is also constant, doesn't depend on time. So the acceleration is 0. So we don't need to find the time t equal 1. But we know that now that when the time t equal 1, the object is passing through the position 3, 0. And now we want to find the speed. The speed is nothing else than the magnitude of the vector velocity. The vector velocity is 3i plus 1j. What is the magnitude of this vector? Is ax squared plus ay squared square root. 3 squared plus 1 squared square root is the magnitude of the vector velocity, which is the speed. So the speed is a square root of 10. So the problem is solved. We have the vector velocity at any time. We have the acceleration at t equal 1, at the time t equal 1, at any time is the acceleration 0, and we have the magnitude of the velocity, or the speed. The speed is a square root of 10. And this speed doesn't change because the velocity, the vector velocity, doesn't change. Let's go to the next problem. Now, the next problem say like this. It's almost the same problem, so I'm going not to explain too much. You will have all the detail. Now it say find the velocity and acceleration and speed at the point 3, 0 for the function r of t 3 cosine ti plus 2 sine tj. This r of t, that is a parametric equation, is a vector value function that describes a curve. R of t describes a curve. Which curve it describes? It's clear for me that what is describing is an ellipse. So the object is moving in an ellipse, around the ellipse, is having a certain change in the position, so it has a velocity v. So starting, we have that the position vector is 3t 3 cosine ti plus 2 sine tj. How we will find the vector velocity? Easy. Make the derivative of r respect to the t. If you make the derivative of r respect to the t, you will find the vector velocity is a vector, have magnitude and have direction. So the vector velocity is tangent to the curve. If the curve is an ellipse, this vector velocity is always tangent to the ellipse, to the trajectory of the ellipse. And now we find the acceleration. What it means, the acceleration? It means the change in the vector velocity respect to the time, the derivative of the vector velocity respect to the time. If we make the derivative of v, of the velocity respect to the time, you will find minus 3 cosine of t, because the derivative of sine of t is cosine of t. And the derivative of 2 cosine of t will be minus 2 sine of tj. So we have the vector velocity, we have the acceleration, and the problem is asking me, when x equals 3 and y equals 0, what is the vector velocity? Well, if we write that x of t is 3 cosine of t, and we say that x equals 3, it means that 3 is 3 cosine of t. So cosine of t should be 1. And t have to be what? T can be 0, because cosine of 0 is 1, or can be 2 pi, or 4 pi, etc. So at this time t, we have to find the vector velocity. How we will do it? We will plug in t equals 0, or t equal 2 pi, or t equal 4 pi into the equation for the vector velocity and for the acceleration. So in the first thing that we are going to find is the magnitude of the velocity. The magnitude of the velocity is the square root of the components of the vector velocity, of 3 squared sine square of t. 3 squared is 9, 9 sine square of t plus 4 cosine square of t. So the magnitude of the velocity is changing. It depends on t. When it will be the maximum magnitude of the vector velocity, at what time t? Well, you have to make the derivative of v respect to the t equals 0, and you will find at what time t the vector velocity is the maximum vector velocity. So at the point 3, 0, at the point 3, 0, at the point 3, 0, t equals 0, or 2 pi. So I plug in t equals 0 into my equation for the vector velocity, and I have that v of 0 is 2j. Why? Well, sine of 0 is 0, 2 cosine of 0 is 1, so the vector velocity is 2 multiplied by 1j, or 2j. If we do the same thing for the acceleration and we plug in t equals 0 on our equation of the acceleration, we will find that at t equals 0, the acceleration is minus 3i. So the picture is something like this. The object is moving in an ellipse. At t equals 0, the position is x equals 3, y equals 0. So it's at the point A. The position vector is this one. The vector velocity at 3, 0 at this point, or t equals 0, is 2j. 2j is this vector, 2j. Meanwhile, the vector acceleration is minus 3i, is this vector, minus 3i. So this is the problem. Finally, we know how to find the speed at the position 3,0. At the position 3,0, which is t equals 0, the speed will be 9, sine square of 0 is 0, 4, cosine of 0 is 1, square root of 4, 0 plus 4, square root of 4 is 2, so the speed is 2. But we see here that 2j is the vector velocity at t equals 0. So the magnitude of 2j is 2. So the problem is done. Let's go to the next problem. Now the next problem is again the same problem. Very similar problem. Find the velocity, acceleration, and speed at the point x, y. X, y. Let's go to write here x, y. X, y. 1, 1. Then the position function, this is a vector value function t square I plus t cube j. What we will do exactly the same. Then we find the velocity as the derivative of the position vector to the t, to the time. So b of t will be r prime of t, which is 2ti plus 3t squared, the derivative of r respect to the t. The acceleration, which is the second derivative of the position vector, or the first derivative of the vector velocity, is 2i plus 60j. So the acceleration, the component x of the acceleration is constant, so they will not change the component x of the velocity. But the component y of the acceleration is 6t, so the velocity is changing. As you see, it's changing like 3t squared is the velocity. So the speed is the magnitude of the vector velocity. So we found the speed, we will find this equation, the square root of the components of the vector velocity. The components of the vector velocity are 2t and 3t squared. So the square root of the square of 2t is 4t squared, 3t, the square of 3t squared is 94, and the magnitude of the vector velocity is the square root of 4t squared plus 94. At the point 1, 1, the time t is 1. How we know that the time t is 1? Well, you write x of t equal t squared. If you impose that the x is 1, it's because t squared is 1. So t should be equal plus minus square root of 1, which is 1. So t could be plus 1 and minus 1. But we choose t equal plus 1. Why? Because y of t is t cubed. So we want y to be 1. So t cubed, it will be the square root of the cubic root of 1. And the cubic root of 1 is when t is equal 1. So for t equal 1 is the time that we choose when the object is at the position 1, 1. There is no any other time. We cannot choose t equal minus 1 because the object is not at the position y equal 1 when t equal minus 1. So what is the vector velocity now? Well, the vector velocity, we know what is the time t. The vector velocity is just the formula that we have found at the beginning, 2ti plus 3t squared, 2ti plus 3t squared. We will plug in t equal 1, it will be 2i plus 3j. This is the vector velocity when the time t is 1 second or whatever. And what is the acceleration? Same thing. If you plug in t equal 1 in the formula of the acceleration, because the acceleration is 2I plus 6tj. If you plug in t equal 1, the acceleration at the time t equal 1 will be 2I plus 6j. And what is the speed? The speed is the magnitude of the velocity of the square root of the components square. Is the sum of the component square. So what is the speed? The speed will be v of 1 square root of the component. The component is 2 squared, 3 squared, 9. 4 plus 9, 13, square root of 13. And the problem is already solved. Again, it's always the same idea how to find vector velocity and acceleration. Let's go to the next problem. So the next problem is an opposite problem. We start with the acceleration and we want to go to the formula for the vector velocity. So in these problems, we start with the formula that the acceleration is the change in the vector velocity respect to the time, and what we say is that the change in the vector velocity is a by ddt. So what we will say to find the vector velocity is that the integral from v equal vector velocity v equal v0 to the final vector velocity v is equal to the integral from t equal t0 until time t. So in case that the vector acceleration is constant, I can take it out the integral, but in general case I have to integrate a vector equation. So what is the integral of ddv? The integral of ddv is v minus v0. So it's the vector v minus the vector velocity. This is the integral from t equal t0, t0 can be 0, to t up to the time t, the upper limit of the vector acceleration ddt. In our case, the vector acceleration is a constant vector, is the vector I plus j. So I will have v minus v0 equal a by the integral vector a by the integral of ddt from t0 to t. So this will be the vector a multiplied by t minus t0. So what will be the vector velocity? The vector velocity will be v0, the initial vector velocity, plus the vector acceleration multiplied by t minus t0. Now let's go to plugging numbers to find the vector velocity. The problem says that at t equals 0, so we choose t0 equals 0. So this t0 is equal 0, and this is t0 equals 0. At t equals 0, the vector, the initial vector velocity is 0, and the position is 0. Okay, so what will be the vector velocity? The vector velocity will be equal to the initial vector velocity. The initial vector velocity is 0 plus the acceleration. The acceleration is the vector I plus j and multiplied by t. So the vector velocity v is b minus v0, b equal, let's go to erase here, b equal I plus j, I, t times I plus t times j. It means that the component x of the velocity is t, and the component y of the velocity is also. Now we have found the vector velocity b. Now we have to find the vector position. So the problem is the inverse problem. They give us the vector acceleration, and we have to find the vector velocity and the vector position. In previous problem, We start with the vector position and we find the vector velocity and the vector acceleration doing the derivative of the vector function. But in this problem, we do the integral to revert the problem. So now we have the vector velocity v, and the vector velocity is the derivative of our respect to the t. What we know in this case is what is the vector velocity. This is the vector velocity. And what we want to know is the position vector. So we'll do like this. ddr, it will be v by ddt. So we integrate at both sides of the equation. We integrate from r0, vector r0 to vector r of ddr vector r equal the integral of b by ddt. The time t varies from t0 to t. And now we have to do this calculation. This calculation is performed like this. R, the integral of ddr, of the vector ddr, is r minus r0. And r minus r0 is the integral of v by ddt from t0 to t. So the vector r is the vector r0 plus the integral from t0 to t of b by ddt. Let's go to plug-in numbers. r0 is 0, so the vector position is 0, so it would be 0 plus the integral from t0 is 0 up to the time t of the vector velocity, but the vector velocity is here, is ti plus tj. So ti plus tj ddt. What is the integral of this expression? Now, the integral of this expression is t squared r of t will be equal t squared divided by 2 I plus t squared divided by 2j, and this is evaluate between 0 and t. So it will be t squared divided by 2i plus t squared divided by 2j, and this is the vector position r at any time t. You see that we have fixed the position vector according to the initial condition. The initial condition is that the position vector at t equals 0 is 0, and the initial velocity at t equals 0 is also 0. And this is the solution. What we have done is find the vector velocity doing the integral of a by ddt. Plug in a, y plus j ddt, do the integral. Impose the condition that the velocity at time t equals 0 is 0, and this will take you that this constant z is 0. Find now the vector position r of t by doing the integral of b of t ddt. Because v of t is ti plus tj, ddt, the integral will be t squared I plus t squared j plus c. Now impose the condition that at t equals 0, the initial position is 0. If you impose this, you will obtain that the c1 constant is 0. Hence, the position function r of t is t squared I divided by 2 plus t squared divided by 2j. And the problem is solved. Let's go to the next problem. Okay, on this problem is exactly the same. It gives you acceleration vector 2i plus 3j. Is a vector that is a constant vector. We have to find the vector velocity and the position vector. We need to find the vector velocity to obtain the position vector. And the two initial conditions that it says is that the vector velocity, the initial velocity at time t equals 0 is 4j. And the initial position at time t equals 0 of r of 0 is 0. This will allow us to fix the two integration constants that will appear in our problem. So, the first equation that we will have, it will be find v of t. We found v of t by doing the integral of a of t ddt. Plugging a of t, we will have that the vector velocity, it will be 2ti plus 3tj plus a constant c. Next step, find who is c. We know that at time t equals 0, the velocity is 4j. So you can plug in here t equals 0, t equals 0. V of 0 is 4j, and you can find that c should be 4. So the second step is done here. So v of 0 is 4j. It allows you to find c. C is the vector c is 4j. Second step, go to find r of t. How you will find r of t? R of t will be the integral of v of t ddt. Plug in v of t, 2t plus 3t plus 4, because we already found that c is 4, 3tj plus 4j, 3t plus 4j ddt. Find this integral, and you will find that this is a very easy integral. The integral will be t squared I, because 2t, the integral of 2t is t squared divided by 2. With the 2 will cancel, will be the t squared plus I plus 3t squared divided by 2 plus 4t, the integral of 4 is 4t in the direction j, plus a new constant, c1. How we will find a new constant? We impose the initial condition. The initial conditions say that r of 0 will be 0. So you plug in t equals 0 in both sides of the equation, and you will obtain that c1, the vector c1, have to be 0. Then what we have obtained is that the position vector r of t for the acceleration a of t 2i plus 3j, the object will move according to the vector position r of t equal t squared I plus 3t squared divided by 2 4tj. And the problem is solved. Now we are going to do the similar problem like the previous problem. It looks more difficult, but indeed is the same problem. It says like this. Let's go to write the equations again. It says like this. Find the vector value function for the path. So what it means is find r of t. So the problem in this problem, what we have to find is the position vector as a function of time. For the path of a projectile launched at a height of 10 feet. So the projectile is launched, this is the x, this is the y, and this is 10 feet, height is 10 feet, and is launched from here. So the initial condition say that the position at time t equals 0, at t equals 0, the position x, y is 0, 10. This is the initial condition for the position above the ground with the initial velocity 88 feet per second. So the initial magnitude of the velocity is 88 feet per second. And now it says that you launch the projectile with an angle of 30 degrees. So you launch the projectile like this, and the angle with the x-axis, with the horizontal axis, is 30 degrees. So the problem here is that you have is a projectile. It's a projectile, and you know that the projectile will do a parabola and will go like this and will fall to the floor at certain point P. And the problem says you launch this projectile with a magnitude velocity of 88 feet per second with the angle is 30 degrees above the horizontal. and it says find R of t. Find what is the vector position. The vector position is this one. It starts like this, the vector position. It starts like this. Later on will go like this. Later on the vector position will go like this. Later on will go like this. When it touches the floor, the vector position will go like this. If there is no floor, the object will go down, and the vector position will be like this, and like this, and like this, and will go down, and will go down with the parabola. Okay, who is R of t? So indeed it's the same problem that we have done. So we start to rewrite again our equation. There is one equation that we need to start to say that the acceleration A of this problem, the acceleration A is minus 32 feet per second squared in the j direction. So the acceleration is a vector that is a vector field that at any point the acceleration is magnitude 32 going downwards, minus j going downwards, and the magnitude is 32 going downwards. So this is the vector acceleration at any point, the same vector acceleration, even if I draw vectors that doesn't look exactly the same. So this is 32 meters per second squared. 32 is the magnitude, and the vector is in the direction minus j going downwards. So the problem says if you have the acceleration, can you find the vector velocity? For sure, we have done before. So now let's go to do it. A is now minus 32 feet per second squared j. But A is the derivative of v respect to the t. So d dv is minus 32 j d dt. And who is v? If I integrate both sides of the equation, I will have v minus v0 equal minus 32 times t. The derivative of 1 d dt is t, plus nothing, because I already wrote the v0. Indeed, the v0 is the c, is the constant. So the equation that I will have is that v equal v0 minus 32 times t in the j direction. Okay, so it will be, who is v0? v0 is this vector, is the vector that have the magnitude 88. This is the vector velocity, initial vector velocity. It has the magnitude 88, and its go in the 30-degree angle respect to the x-axis. So the vector velocity v0 will be a vector that has the magnitude 88. The component x will be cosine of 30 in the I direction, plus in the direction, in the j direction, there will be velocity. So what I'm doing is to decompose the vector velocity v that have the magnitude 88 in two vectors. One vector, this is 30 degrees, one vector have the magnitude 88 cosine of 30. And the other vector, it will have the magnitude 88 sine of 30. And the sum of the two vectors will be the initial vector v0. So v0 is 88 cosine of 30i plus 88 sine of 30j. So I will plug in and I will find v of t. So v of t will be v0. v0 is 88 cosine of 30i plus 88 sine of 30 degree j minus 32 times t by j. Because I know how to solve vectors, v of t will be 88 cosine of 30i plus, open parentheses, and put the j components, it will be 88 sine of 30 minus 32 times t in the j direction. So the velocity v have an x component, vx, and a y component, vy. So this is the vector velocity. Cosine of 30 is a square root of 2 divided by 2. Sine of 30 is 1/2. So you can plug in the numbers and having nice number like this, but it's the same. So who is r of t? I know what is v of t. V of t is the derivative of r respect to the t. So who is r of t? So ddr is v ddt. How I will find r? I will make the integral from r0 to r. I will make the integral here from t0 to t. You see the r is related, the vector r, with the time t. And the r0 is related with the time t0. So what is the integral of ddr? The integral of ddr is the vector r minus r0. And r minus r0 would be the integral from t0 to t of the vector velocity v. The vector velocity v, it will be 88 cosine of 30i plus 88 sine of 30 minus 32 times t in the j direction, ddt. So it will be r of 0 plus what will be the integral of 88 cosine of 30? It will be 88 cosine of 30 multiplied by t in the I direction. What will be the integral of 88 sine of 30? It will be 88 sine of 30 times t in the j direction minus 32 times t squared divided by 2 in the j direction. So I found the r. The problem says that the initial position is the zero vector. It say like this. It say above the ground. No, the initial position is the vector 0i plus 10j. So the equation that I will find is that the r0 is 0i plus 10j plus 88 cosine of 30 times ti plus everything on the same thing, 88 sine of 30 tj minus 32 t squared divided by 2j. So if I write this in a good way, the I will be 88 cosine of 30 t I, and now I will put all the j here. I see a 10, I see 88 sine of 30 times t, and I see 32 t squared divided by 2, everything in the j direction. So the x of t is this plus y of t is this. So the x of t is 88 cosine of 30 times t, and the y of t is 10 plus 88 sine of 0t minus 32 times t squared divided by 2. If you check a physics textbook, the x of t is v0x by t. You see, v0x is 88 cosine of 30. And the y of t is the 10, that is the y0, plus v0y, because 88 sine of 30 is v0y, is the component y of the initial velocity, by t minus 16 times t squared. Minus a divided by 2, we can write it like this, minus a divided by 2, 32 is a, 32 is a, 32 divided by 2, t squared. So we have done the problem. So this is the equation, and let me read what it say the problem. It say this, find r of t. So we found r of t. So if you give different values for t, it will start, the r of t will start here, for another time t will start here, another time t, the position vector will be like this, will be like this, will be like this. And at the end, the trajectory will be a parabola. From where I can see that this is a parabola, it's not difficult to see that this is a parabola, because if you see here, the x of t is v0x, a number, 3, 5 by t. And the y of t is y0, the initial height, plus v0y by t minus a divided by 2t squared, where a, in the case of a gravitational acceleration in the Earth, is 32 feet per second square, or if you want to express in meters per second square, it would be 9.8 meters per second square. So how I will find that this is a parabola? Well, if you take the t will be the x divided by v0x. If you plug in the y will be y0 plus v0y by t, x divided by v0x, minus 1/2 a by t squared, x squared divided by v0x squared. And this is the equation of a parabola. It's of the form ax squared plus bx plus c. The a will be this, well, this a is confused with the acceleration. Maybe we call it with another name. Is of the form alpha x squared plus beta x plus c. So this is a parabola, and this is also a parabola, and the problem is solved. Then, to make the summary, we found the position vector r of t like 88 cosine of 30t plus 10 times plus 88 sine of 30t, and this is the equation that we have found. And if we plug in the numbers will be 44 square root of t, because cosine of t is square root of 2 divided by 2, and sine of 30 is 1/2, so it will appear, instead of 88, it will appear 88 multiplied by 1/2 will be 44. And then the problem is solved, and this should be exactly the same that I did before. The position vector is this one. Let's go to the next problem. So these problems, problem 9, it says A baseball is hit from the height of 2.5 feet. So 2.5 feet is something like this. So this is the ball. The height is 2.5 feet. Above the ground with an initial velocity of 140 feet per second at an angle of 22 degrees. So the angle is now 22 degrees. And the initial speed is 140. So the magnitude of the vector in this direction is 144. So we know that in the x direction there is 140 cosine of 22 in the x direction of velocity. And there is velocity in the y direction in the amount of 140 sine of 22. So what are the equations that we have to use? What the problem is say, will the ball clear a 10-foot high fence located at 375 feet from home plate? So there is a fence that is located, this is the initial, the x equals 0, and at x equals 375, there is a fence that is 10 foot high. So the fence is 10 foot. So the ball will do a parabolic motion because it's in the presence of a gravitational acceleration, and because everything is in feet, I will use minus 32 feet second square. So the ball will do a parabolic motion, and we don't know if the ball will do like this, or maybe will do like this, or maybe will do like this and will overpass the wall. So the question is, will the ball clear the 10-foot high fence located at 375 feet? How I will do, I will find the vector position when x equals 375, and I will see what is the y component of the vector position. If the y component of the vector position is higher than 375, it means that it will pass the fence. Okay, let's go to do it. According to the previous problem, the position function of the ball when the acceleration is minus 32 feet is v0x. This is v0x times t I plus v0y, which is 140 sine of 22 t in the j direction, plus the initial position. Let's go to write the equation is v0x t plus y0 plus v0y t minus 1/2 of the acceleration 32 t squared, everything in the j direction. This is the equation that we have used in the previous problem. So when x is 375, what is the time t? When x is 375, you plug in here, this is the x. You plug, this is the x, this is the x. When x is 140 cosine of 22t, who is tan t? When 300, so you are solving this equation. 375, which is the x, is 140 cosine of 22 times t. Oh, what is t? T is 375 divided by 140 cosine of 22. So this will give you the time t equal 2.88 seconds. So at the time t, 2.889 seconds, the object is at the x 375. And for this value of the time, who is the y? The y is here. This is the y. Because remember that r of t is x of t plus y of tj. X of ti plus y of tj, this is r of t. Perfect. So at this time t, who is y? For this value of t, the y is 20.5. So if you plug in the time t, here 2.899 seconds, and you find the y, and here 2.899, and you find the y, you will find 20.5. So you pass the fence. So the ball clear the fence. And the problem is done. So the position function you know, and the problem is solved. Now let's go to problem 10. This is the last problem. It says determine the maximum height of a projectile fired at a height of 1.5 meters. So the y0 is 1.5. So this is 1.5. Above the ground with an initial velocity of 100 meters per second and an angle of 30 degrees. So this is 100 meters per second and the angle is 30 degrees. And now we have to use the acceleration equal minus 9.8 meters second squared because the unit that they are talking is not feet, they are meters and second. So we can use minus 10 meters per second squared like an approximation. So how we will do this problem? How we will find the maximum height? When it will occur the maximum height? This is interesting. The object will do a parabola. Okay. The maximum height will occur somewhere here. When it will occur the maximum height? If you see, the vector velocity at this point is 100. As you move, the vector velocity is changing. It's changing the direction and it's changing its magnitude. But at the maximum height, the component x of the velocity exists, but the component y of the velocity vy should be 0. The component y of the velocity is 0, so using this idea, we can find the maximum height, h, that is what is asking us. So let's go to do it. So the position vector is, you know, because we have done this problem here. Now we use 9.8 divided by 2, which is 4.9, so instead of 16. So the position vector will be now r of t will be v0x, r of t will be x of t I plus y of t j. So the x of t is this part, the y of t is all this part. So the x of t is v0x by t, and the y of t is y0 plus v0y by t minus 1/2 a by t squared j. So this is the vector r of t, and if you plug in numbers, you will obtain v0x is 100 cosine of 30 times t in the I direction, and this is y0, 1.5, v0y is 100 sine of 30 times t, minus 1/2 of 9.8 will be minus 4.9 t squared j. So the maximum height we said is arrived when the velocity v is by equals 0. And how we will obtain this velocity. So we may find the vector velocity v of t, but we may do something else. We may find, you see, the y is increasing, 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 and now it will decrease the y. The maximum point will be when the derivative of y respect to the t is 0. So this is y of t. Also, the maximum will occur with the velocity v0x, v0y. So this is y of t. If I plug in this expression or this expression equals 0, I will find a time t at which the derivative of y respect to the t is 0. So the maximum heights occur when the derivative of y is equal 0. So I have y of t, which is all this expression, or which is all this expression. I will make the derivative of y respect to the t, the derivative of this constant is 0. The derivative of this is 100 sine of 30, the derivative is 1, minus 2 times 4.9 by t. So let's go to do it. The maximum will occur when the derivative of y respect to the t is 0, and the derivative of y respect to the t is 0 when the component y, the derivative of y respect to the t, is simple 100 sine of 30, 2 by 4.99, 9.88 t is when when the derivative of this expression is 0, and this happens when 100 sine of 30 is 9.8 by t. So this means that at the time t equals 5.102 seconds, it achieved the maximum height. So the maximum height is, you plug in the time t equals 5.10 in the expression of y, and you will have y equal 1.5 plus 100 sine of 30 multiplied by t minus 4.9 multiplied by t squared. So the maximum height of the parabola will be 129.1 meters, and the problem is solved.